So we got this bullet. So I'm going to say the bullet is M1. M1, the mass is 0.03 kilograms. The initial velocity of the bullet is V1 initial, and they give that to us as 200 meter per second. Now the baseball is M2. That's 0.15 kilograms. And what is the initial velocity of the baseball before the collision? 0. It's just sitting there. Okay. Okay. Whenever you see a collision, what can you apply to the collision? Conservation of momentum. Does it matter if it's elastic or inelastic for applying conservation momentum? It doesn't matter if it's elastic or inelastic. Momentum is always conserved. By the way, is this collision here? They don't tell us in the problem, but is this elastic or inelastic? Inelastic, right? How do we know it has to be inelastic? Well, the bullet's going to do what to the ball? Rip a hole in it, right? The bullet's going to go boom and rip a hole into the baseball. Does that take energy to rip a hole into a baseball? Yeah. Where's that energy going to come from? The initial kinetic energy of the bullet. So we're going to lose kinetic energy in the collision to deforming the baseball. Okay? And again, if the problem doesn't say elastic or inelastic, what is it? It's inelastic. If they don't mention what type of collision it is, assume it's inelastic. Okay, so how are we going to approach this problem? What they want us to figure out is how high the bullet baseball combo rises after the collision. So look, the collision happens right here. The collision happens right here. And then what happens as a result of the collision? The bullet baseball combo is going to go up, 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 up to a point up here. And the bullet's inside the baseball. Okay, and what they want us to figure out is how high it rises. Okay? What do we need to know before we can figure out how high it rises? What do we have to figure out first before we can solve for this h? What do we got to figure out? The velocity final after the collision. After the collision, the bullet baseball combo is going to take off with some final velocity, right? Which would be the initial velocity for the second part. Does that make sense? So how are we going to get this velocity right after the collision? We're going to apply what? What can you always apply to collisions? Momentum. So we're going to go M1, V1 initial, plus M2, V2 initial. The two objects stick together. So what do they share final? The same final velocity, so we can just go M1 plus M2, V final, that's the total final momentum. What's the initial velocity of the baseball? 0. So now we can solve for V final. So V final is going to be M1 V1 initial over M1 plus M2. So M1 is 0.03. V1 initial is 200. And then the combined mass of both objects is 0.18. So this gives a V final after the collision of 33.3 meter per second. Okay? So now that we know that, so this V final here is 33.3 meter per second. And by the way, what's the velocity at the very highest point? 0. It goes up, 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 and then stops for a split second. So how can we figure out the height that it goes to now? Well, you could either do kinematic or conservation of energy. So what should we do? Should we do kinematic or conservation of energy? Should we do, okay, let's do kinematic. So using kinematic, you go Vf squared equals V initial squared plus 2AH. H is the distance there. What's V final at the top here? 0. So H will be negative V initial squared over 2A. And by the way, what's the acceleration as it rises? It's gravity. How do I know it's gravity? Because it's a projectile now. It's in free fall. The only force on the object is gravity. So this is going to be negative 33.3 repeating meter per second squared over 2 times negative 9.8. And the negatives cancel, and you get 56.7 meters. So that's the height that it would go to. Now look, if you would have done conservation of energy, so what type of energy do we start with right after the collision? The second the collision's done, what type of energy do we have right here after the collision? Kinetic. That kinetic gets converted to what? Potential. This is chapter 5. So look what happens here. So you can say the kinetic energy right after the collision ends is equal to the potential energy of gravity. Kinetic here goes to potential here. So kinetic energy is 1/2 mv squared. Potential energy is mgh. The m's cancel. H is going to be v squared over 2g. Look at these two equations. V squared over 2, that's conservation of energy. That's kinematic. It's basically the same thing. You end up with the same thing.